Hey guys, Katie from Katie's Classroom here. Today's video is going to be teaching you about composite functions, just a few examples, some quick and easy tips to get those composite function problems done. So let's get into it. Here is our first example for composite functions. You will be given two functions and then basically asked to put one inside the other. So an example of this would be, you might be asked to take these two functions and find f of g of 4. There are pretty much two main ways to go about this. I do prefer one over the other, but for the first example, I'm going to show you both ways to do this. So the first way that I see a lot of teachers do, especially if you don't have a 4 and you just have an x here, is to start by plugging in whatever you have here for g of x into f of x. Okay, so we have 5 times x, and x is going to equal 3x squared. So you take 5 times g of x, 3x squared, and then plus 3. So see how I took all of g of x and I just plugged it in for x in the f of x. So this would be 15x squared plus 3. And then we can't forget the 4 part, so you would take and do 15 times 4 squared plus 3. So this is 15 times 16 plus 3. So 15 times 16 is 240 plus 3 gives us 243. So that's one way to do this. Over here, I'll show you the second way, and this is actually the way I prefer to do this. So we're finding f of g of 4, and here are our functions. I like to find kind of whatever's on the inside first, so the g of 4. So I find g of 4 by plugging 4 in for x. So this is 3 times x squared, so we're going to do 3 times 4 squared. Well, 4 squared is 16, so this is 3 times 16, and 3 times 16 is 48. So then you take this 48, and you're going to plug it into f of x. So we're finding f of 48. So 5 times 48 plus 3. So multiply 5 and 48, add 3, and you still get 243. So you can do this either way. I prefer the second option, so for the rest of the video, I'm only going to do my examples using the second option. All right, here is a second example. We've got f of x equals 2x plus 7 and g of x equals 3x minus 2. And we're going to find g of f of 6. And before we get going on this, I do want you to realize that you may also see this written as g of f of 6. So these are written both ways, and they're asking you to do the same thing. So I'm going to start by finding f of 6. So f of 6 equals 2 times 6 plus 7. So 2 times 6 is 12 plus 7 is 19. So now we're going to be finding g of 19. G of 19 is equal to 3 times 19 minus 2. You get 57 minus 2, so this equals 55. Okay, we're going to make the third example a little bit more challenging just by putting in a fraction. It's really not that bad, I promise, don't freak out. So we're going to find g of f of 10. So I'm going to start out by finding f of 10. So f of 10, negative 1/5 times 10 plus 4. So when you do negative 1/5 times 10, that's the same as 10 divided by 5. This is going to be -2 plus 4. So f of 10 equals 2. And now I'm going to take that and find g of 2. So 4 times 2 squared. Order of operations tells us to do the exponent first. So 2 squared is 4. This becomes 4 times 4, which is 16. All right, we have the same two functions here, but now we're going to switch this around and find f of g of 10. We did it the other way around in the last problem, but I want you to try this one. So get something to write with and work this out. Pause the video, come back and see if you got the correct answer. All right, so when you did this, hopefully you started with g of 10, and you should get the g of 10 is 400. And then you take that and you're going to find f of 400. And f of 400 is -76. So that would have been your final answer. If you didn't get that, I would go back and try again and try working towards these two answers. And that is the last example I have for you.
Alrighty, well that's it. I hope you feel like composite functions are more easy now. If you are still confused, make sure you are always asking your teacher for help, or you can contact me. I would love to help you and be your math tutor. Hopefully math is now a little less scary, and I will see you next time. Thank you, bye.